including some that are very distant from us on the evolutionary tree. Among them are the cephalopods, including octopus, squid, and cuttlefish.
Cephalopods are mollusks. They're related to clams and oysters, but they don't look much like them at all. And in the evolutionary terms, they've evolved in a very different way.
Roger Hanlon has spent the last 30 years studying the behavior of these animals. Behavior that is their main defense from ending up as dinner.
These animals are a yummy hunk of protein swimming around in the ocean, and once they're caught, they have no defenses. So they have to have a good primary defense. That's camouflage. Don't be seen. You can move over to this tank here.
In the lab, Hanlon and his team study how cephalopods, like this cuttlefish, control and change their skin patterns.
It's taking that visual information and translating it to the skin on the back. This is beautiful. Look at that perfect white square.
To see how they apply their tricks in their natural habitat, Hanlon tails them with his underwater camera. His biggest challenge? Finding them in the first place. Octopus and cuttlefish have an uncanny ability to completely disappear into the background.
We all think of the chameleon as sort of the king or queen of color change, but that's not true. A cephalopod can show many more patterns and can show them instantaneously. An octopus can be so camouflaged you literally cannot see it. So every place they go, they are morphing into something that looks a lot like that environment. So here's the scene. You've got a rock with algae all over it. There appears to be nothing there except the swimming fish going by. Okay, so take a look here and just watch for a moment. And there it is. Whoa. Isn't that amazing? This animal was completely camouflaged on that rock, and suddenly it was there.
This remarkable camouflage, changing both pattern and three-dimensional texture, is performed by skin unlike any other animal's.
It's an amazing skin because there are up to 20 million of these chromatophore pigment cells, and to control 20 million of anything is going to take a lot of processing power. We call it a computer. Animals have brains. These animals have extraordinarily large, complicated brains to make all this work.
For Hanlon, the brains and sophisticated behavior of these animals suggest that there's more than just one way to get smart.
Very inquisitive animal. That's quite extraordinary. Even an invertebrate animal related to a clam or a snail can develop an incredibly complicated brain. This is one of the true wonders of nature. It's hard to explain why, but it's everywhere. And what does this mean about the universe? And